Hello everybody, in this video we will be performing basic dynamic analysis on the malware. So first off, the tools required for this analysis are netcat, which is run in the command prompt. So to run netcat, we enter nc for netcat, -l for listening, -p for the port, and we show the port number. So netcat will be in charge of monitoring any outbound connectivity within those ports. So next will be rec_shot, which will compare registry keys in the system before and after the execution of the malware. So I'm gonna take the first shot. Next will be a pet DNS. A pet DNS will be spoofing a DNS server since there is no internet connectivity within the virtual machine itself. So the DNS reply will be the host itself, which is this address. So after you enter this address, start the server. So the next will be Process Explorer, which will show all ongoing processes that are running in the system. Last but not least will be Process Monitor, which will be run later on. So now we try to start everything. So once everything is started, we run Process Monitor, click OK. So now we'll run the malware itself, which is service.exe. So the first thing we'll be monitoring is the Process Explorer. So I'm gonna pull the screen up, and now we'll activate the malware itself, service.exe. So as you can see, upon running, you can see a new process, service.exe, is executed and is created and is running in the background. So here you can see more detail of the malware itself or the process. So first off, you see a lot of detail, but one particular information is that the malware created a mutex called service.exe. So mutex or mutant are normally created in order for malware to not reinfect the same host again. So the malware probably created this mutex for that very reason. So if you go to View, Lower Pane Panel, DLL, you can see all the DLL that malware calls. So if you want to inspect further, you can right click on it, right click on the process, click on Properties, and you can view a lot of details here. So we're gonna look at strings. Since thread, there's only one thread, so it's not really that important. So we go down. Since I already scanned through this, I discovered a few interesting strings from the process itself. So let's check. So first of all, you see create new text. So it's evident, just now we found out that the malware or the process itself created a mutex. So in the string you'll see a mutex. And another string that is quite interesting is create file. So possibly the process itself created a file. So if we go down further, we'll see many other interesting things. So another one will be pick message. What pick message does is it checks the message thread of the system, and if there is any message being sent, it will retrieve it. So this is most likely used to log information or record information by the user. So as we go further down, we will see more, such as get keyboard state, get keyboard layout, which is related to the keyboard. So after that, there isn't really much else to the string already, except for maybe all these strings which are set register operations which manipulates the registry keys, so we can kind of gauge that the malware itself will be performing some registry operations or log information logging operations or file creation or maybe file deletion, as we see. So now we'll look at the process monitor. So in process monitor, since there are so far there's a lot of events going on, so to ensure that we are able to see what is required, we set a filter. So first off, we set the filter to process name to the service.exe, which is the malware's name. So we add it, then we apply a filter. We take away, remove those that are not required, and then we apply filter. So you can see from here there's a lot of events under service.exe. So if we go down, we'll see quite a few that are standard calling of the DLLs, standard events that requires the DLL. So if we look further down, so as you can see here, as you can see here, there's a open registry key, which is to run something, which is a registry key open to run something whenever the user logs in. And then next you can see that the malware creates an identical key which is the same and sets the value to run the malware, which is service.exe, whenever the user logs in. So this newly added key will be allowing the malware itself to be run whenever the user logs in into the system. So you can see here also, you can see that the key is queried by the malware itself to check whether the key has been there. So now we apply another filter to maybe better understand what the malware is trying to do, maybe create file. So we go to operations, is create file, add operation, create registry key maybe, and yeah, let's try this first. Apply. Okay. So as we go further down, basically we have to look for, so you can see a lot of information here. Okay, so we reverted to the old filter, which was just finding process with the name of service.exe. So from here we can see quite a lot of things that are being done by the service.exe. So if we continue further down, so we see quite a few create files, all this. Well, there are some interesting ones. So here we can see some registry key manipulation. So if we continue further down, so all these are some simple basic registry calling. Yeah. So here you can see more queries, more simple and standard DLL callings, registry callings. So the ones that we want to see are keys that are like creating registry keys, which are important, which shows that the malware is trying to create new. So you can see that the malware tries to open, like try to find keys, like create keys such as this. In this case, we can see the malware tries to create a registry key to run something. So what this key does is to ensure that whatever that the malware run, which is after the run here, will be executed whenever the malware or the user logs in the system. So after the creation of this key, we can see that the key has been set with additional information, which is service.exe. So what does this key does? So this key will ensure that service.exe will be executed whenever the user logs into the system. And normally this happens when the system starts up. Okay, so from here, continue looking for more data. And from here you see that the malware creates a file in this location, which is called log files, and the path is shown here. Another file that is created is visited sites, which is found under this path. So the name of the file itself, log file, is quite suspicious as it gives us the impression that log data or recorded data is being stored here, since it's called log files and the data within the files would highly be log data. So here, for visitor sites, the creation of visitor sites, it gives us the impression as well that the malware is trying to record and store data, or maybe data of websites visited by the user are stored here. So another one would be another file that is being created is called app. So possibly this will be store all the apps that the user uses. So if we go further down, we will see that the malware does more registry manipulation. And if we continue further down, we will see that the malware does something to the related folder. As you can see, write file. And first of all, the malware creates a file, which is the name, which it created a data file under the folder log files, and the name of the file created is the date that the date where the data is logged. So most probably this malware will be logging data and then storing them under the name of the date when the data was logged. So from here you can see read file, it attempts to read and write to the file, which will most likely contain the log data, and then we'll close the file. So from this data we can infer that the malware is trying to log data and save data into this folder under the name of this, which is under the name or under the date where the data was logged. So now we go further down, you see got else. So one thing that we found out is that once you see this is the end of the list, but however, if I type something in my keyboard now and then I go down to the list, and you can see that additional events were found. Log file, new the data file, which is the date where data is logged, has been edited and has been written. So from this we can tell that once you enter something, or if the user types in anything into the keyboard, the malware would record and store it into the log files data file, which is this. So with the discovery of the addition or the write file event that occur, it gives us a very strong understanding of what the malware is possibly doing. And from what we can see, the malware is trying to log keystrokes and also visited sites that the user visits. So other than that, there isn't much events that are suspicious other than those standard callings, such as shell, all those that are not suspicious. So all these log data are the ones that are suspicious, so it's better to take note of those. So now we'll take note at another tool, which is the red shot. So now we'll take the second shot of red shot to compare the registry of after the execution of the malware. So while this thing is calculating, we'll look at netcat, and from what we can see, there is no activity recorded in the netcat. So this shows that the malware does not make any attempts to connect to any external connection. So now we can just move aside and compare the registry keys. So you can see from here, a new value or new registry key has been added into the system. So you can see Microsoft and current user run.exe, which means that service.exe, the program, will be run at the startup of the computer. So we know that the registry key will be added since we have discovered that in the process monitor where new registry was added into the system. So from this you can tell that the malware will be executed whenever the system starts up. So we look at a pet DNS, and there are quite a few IP address, which is this. Actually there are only 3. So these are a few possible IP address that the malware attempts to connect. However, since when we look at netcat, there isn't any connectivity, so that it is highly unlikely that these IP addresses are being requested by the malware. So now that we have finished analyzing the malware with the tools that are required for this analysis, there's another way of analyzing the malware which is still considered dynamic, which is to look out for any physical or any changes on the screen display after the malware has been executed. So for us, we discovered that upon execution of the malware, a new taskbar icon has been discovered. So we hover over it and it says free keylogger. When we click on the icon, a pop-up menu appeared, and in the menu there is a lot of evidence showing that this is a keylogger. So a few are to monitoring, and the name itself is called free keylogger 3.9, which is probably the interface, name of the interface or the menu that the attacker uses in order to configure the malware to log according to its settings. So as you can see here, it says keystrokes, web browsing. So all this will probably cause the malware to do different kinds of recording of information and storing of them. There is even an email delivery option which sends reports, and those reports are highly likely to be the log data to a certain email of that you can specify. So through this you can already tell that this malware is a keylogger, since this interface is most likely should only be accessed by the attacker himself, him or herself, and not the victim. When we try to exit of this pop-up menu, there's even a option where the icon will be hidden from the tray, which means if the attacker were to say click yes here, the icon wouldn't even be appeared here, so the victim would have no clue that the malware is being executed at the background unless he runs task manager or like what we did, process monitor and explorer. Okay, so with that brings to the end of our basic dynamic analysis. I hope you enjoy, and thank you.